The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content.
Taking time. Great. So at this time, I'd like to introduce Dr. Mary Christiansen.
Thank you. Dr. Sutter, Larry Sutter, was asked to give this presentation, but he couldn't make it because he's chairing the 232 Fly Ash Committee. So I haven't been a PhD student in 5 years, but I guess I'm still doing stuff. So, just kidding. Achieving sustainability by use of alternative cements. So, we've seen a lot of presentations here on all the different things that we can do to Portland cement systems. This presentation is saying, okay, what if we forget Portland cement altogether and see what other kind of binders we can look at out there. So why alternative cements? Obviously, environmental impact is a huge one, probably why most of you are in this room right now. We know, I didn't put anything in this presentation because I think it's been said many times today, but a significant amount of CO2 comes from production of Portland cement. So if you just look at whole other binders that don't require calcination of limestone, burning of fossil fuels to that extent, right, you can kind of, right off the bat, lower the carbon footprint potentially. I'll talk about several different types of cements, and you'll see that there is some calcination involved in different CO2, I guess, emitting activities, but we're not getting up to those internal kiln temperatures of Portland cement. And then we also don't have calcium carbonate as a primary material in most of these cements. Additionally, many of these cements are made primarily with waste materials, fly ash or slag, etc., materials that don't usually have a carbon footprint associated with them to start with. So when we look at alternative cements, not only are we looking at the environmental impact, but we're also looking at the life cycle cost. There's one of the talks earlier, right, talked about looking at all of the entire, the durability, the longevity of a material, eliminating the need for maintenance or replacement, that kind of thing. And then you do start to kind of link those two things to sustainability. And then alternative cements, I think many people think that an alternative cement means you would completely replace Portland cement concrete with this other new concrete. There are a couple alternative cements that could potentially play in that, at that level, but many of them are very specific to unique properties that they have, and so they would be more application-based versus just a blanket switcheroo of Portland cement concrete in this new cement. So looking at some of the unique properties offers new materials that could potentially outperform Portland cement in specific applications. So just to give a little bit of background, Dr. Sutter, Dr. Hooten, I think there's about 10 of us that were on an ITG for the last 5 years or so on alternative cements. And we recently became a committee. This is our second convention, I guess, as a committee on alternative cements. And so we just came out with a couple of documents, and so this presentation kind of follows the document, and I'll say a little bit more about it at the end, but if you do have more questions about specific cements, I would hope that you would go read those, because we spent a long time writing them, as you all know. So the definition, which we went around in circles for a long time, is how do you define an alternative cement? It's kind of hard, like it doesn't seem like it would be that hard, right? But it's like, well, it's not a Portland cement, it's not a blended cement, it's not a supplementary cementitious material, right? And so this is the definition that we have right now, and as a committee we'll revisit this, of course. But in an organic cement that can be used as a complete replacement for Portland cement, Portland or blended hydraulic cements, that is not covered by applicable specifications for Portland or blended hydraulic cements. So we're not really looking at binders where you're replacing, where your base is a Portland cement binder and then you're replacing part of it with something else. We're looking at a whole switch. And the way that we've classified these alternative cements is into three different categories: clinkered alternative cements, calcined alternative cements, and non-clinkered alternative cements. And so I'll go through each one and give a couple of examples. So clinkered alternative cements are those cements that are made similarly to Portland cement. They might go through some sort of calcination process, but there's some sort of change. And so as a committee, we identified, or as a group, I guess, task group, we identified what types of those cements that are kind of emerging or have been used in the past, and then identified further the ones that really we have some good data on. And so in this category, the calcium aluminate cements and calcium sulfate aluminate, sulfoaluminate cements are the two that have come to the surface. So calcium aluminate cements, very rapid setting compared to Portland cement, similar strength, typically used as repair material. So again, you're not going to build a building probably out of a calcium aluminate cements, but used for airport runway repair, things like that. There can be some issues with conversion from unstable phases to more stable phases, but researchers have kind of figured out ways to handle that. A lower carbon footprint typically than Portland cement. Calcium sulfoaluminate cements could be more of a direct replacement for Portland cement concrete, typically a more rapid set. It can be expansive sometimes. Corrosion resistance can be kind of an issue. Sometimes the pH is lower. Calcium sulfoaluminate cement is essentially a reactive B-lite cement. So normal Portland cement has lots of A-lite, right? If you, I guess, lower the clinkering temperature down, you would kind of stop when you start to get the B-lite, and then the sulfoaluminate's added in to get a little bit higher early strength. So another good cement. Calcined alternative cements, we're looking at mostly magnesium-based binders. So magnesium oxychloride cement, magnesia and magnesium chloride combined with water, and you end up with a really good patching material. There are some issues losing strength when it gets wet early on, but good fire abrasion, ASR freeze-thaw resistance. Magnesium phosphate cement, similar to MOC, except in this case it's been phosphate has been the acid that's been added. Very rapid set compared to Portland cement, often used for patching. So a lot of these cements, again, are very specific to certain applications. And then the third category that we looked at were non-clinkered alternative cements, and we defined these as cements that require no pyroprocessing but need some sort of an activator to react. Okay, so in this case we're mostly looking at alkali-activated materials. Fly ash and slag, glass is kind of an emerging material, and then supersulfated cements. So alkali-activated cements are sort of the umbrella, I guess, category that you would use, and then depending on the composition of the material that you're activating, you often hear geopolymers. So if you have a low calcium material such as a class F ash or glass, you might call that a geopolymer. If you're activating a slag or a class C ash, you might still just call that an alkali-activated cement. But these are not hydraulic cements, can have a rapid set. As we all know, probably when you're looking at high volumes of fly ash or slag or glass, actually, the composition of that material has a super big impact on their performance. So if you have a class F ash or a class C ash, obviously you're going to get a whole different material. Every time my background is in geopolymers, and whenever I have a discussion with anyone about geopolymers, it seems like we always all be like, end up like, because it's, you change one little thing and properties change, which is cool, right? Because you can kind of really tailor, but also very problematic. So that was probably not a good plug for geopolymers there, sorry. I still think they're great. But anyway, the fly ash, source does matter a lot. So I would say fly ash geopolymers are probably the material that you hear most commonly directly compared to Portland cement concrete. Alkali-activated slag. Slag, of course, typically has more calcium than fly ash or Class F fly ash, of course, where you do need to consider the amount of fly ash when you look at what kind of activator you would use. So those unfamiliar, sorry, I guess I should have said, with alkali-activated cements, essentially you take a material rich in silica and alumina, okay, amorphous ideally, and react it with a high pH activator, so sodium hydroxide, potassium hydroxide, sodium silicate. And it sort of just pulls it apart and polymerizes it back together, kind of like Jello. And you can do this with a very wide variety of materials. Essentially anything you would want to, you can use natural pozzolans, you can use pretty much any pozzolan that's out there to do that, but you will get, like I said, different properties. One of the other things about alkali-activated cements is that they do require, in many cases, a heat cure. So if you mix it up and set it on a table, nothing's going to happen. But if you put it in the oven for 24 hours, you might get up to 8,000 psi one day, no problem. So that is kind of a limiting factor right now, but applications like precast could be a good place for that. So again, performance varies. Supersulfated cement is essentially blast furnace slag that's been activated with calcium sulfate. So there's some anhydrite and Portland cement that's added to the slag, and a little bit less knowledge about this cement than some of the others, but does have good durability attributes, sulfate resistance, low heat of hydration, etc. So, like I said, if you'd like more information about any of these, we have a really good reference right now, a resource to give you kind of a heads up on the chemistry of these. I mean, I guess I didn't know how deep to go in. I didn't go very deep at all, as you can see, but the chemistry between a lot of having to do with the formation of a lot of these cements is extremely different than Portland cement hydration. And so there's kind of a learning curve, I think, when you're looking at a new cement, but the benefits can be pretty significant. So right now, if you're interested, I guess, in alternative cements, there's a lot of research to be done. One of the problems that we have right now, I think, with many of the alternative cements is that most of our testing specifications and standards are written for Portland cement. And a lot of these alternative cements, as I said, maybe requires a heat cure, right, or just a basic change in its formation, and then it would kind of exclude it from whatever that test is. So there's a need for not only learning more about how these cements work, but also how to test them, how to compare them against each other. So like I said, specific mixing procedures, curing are kind of two of the main ones. But one of the goals of the committee and of the document was to kind of take note of what cements are out there, what can they do, how do they work, how are they going to, what needs to be done in order to help you use them. So the report, I'm just going to give a little commercial, I guess, but the report on alternative cements goes through background and drivers, kind of, why are we looking at alternative cements, compares it a little bit to Portland cement as a control, and then goes through technical information on all of the cements I mentioned earlier, and then it gives a pretty good overview of what the current testing requirements are for a wide variety of properties, and then which cements they don't work for. Okay, so if you're looking for some research, there's a whole lot to be done. We also came out with another document called the Practitioner's Guide, which was aimed more at users. So if you're a user out there that's interested in calcium aluminate cements, you heard about them, you've heard what they can do, but you maybe don't know how to use them. A practitioner's guide doesn't necessarily say how to mix one, but it says what kind of questions should you ask someone that's going to be producing that potentially for you. So there's some pretty awesome materials out there. I think it's just a matter of communication and learning, and accepting that it's just a lot of different new chemistries. So some of the committee goals, as I said, are just to kind of be a nucleus for all of this information. There's a lot of different cements out there, and they're all very different. And so one of the things we're doing right now is working on tech notes for each of the main cements that I mentioned. So if you're out there and you have some knowledge on one or the other, I would welcome you to come to our committee meeting tomorrow and volunteer to help. Because we have a lot of, we really want to get some information out for people to have an idea of what these cements do, what the benefits are in terms of the environment, and also what properties they can offer. So here's my real commercial tomorrow, 12 p.m. And we have a mini session, recent advances in alternative cements, that cover many of these, that has pictures. I don't know why I didn't put any pictures in this, I'm sorry. I was like, I hope none of my students are here, because this is the worst. Yeah, anyway, sorry I didn't put any pictures in here. But there's pictures in the ones tomorrow, so you should come see those. Yeah, so, lots of very exciting things going on in the world of alternative cements. If you want to hear more, come tomorrow. And thank you.